Radiometric dating is a way to find out how old something is. It uses the natural breakdown of radioactive materials called isotopes. Each isotope has a specific half-life, which means it takes a certain amount of time for half of it to change into a stable form. Let's take a look at some of the most commonly used isotopes and how they work. Part 2. Commonly used isotopes and how they work. Carbon-14 is an isotope that's constantly being created in the atmosphere. Plants and animals absorb carbon-14 throughout their lives. Once they die, the carbon-14 starts to change back into carbon-12. It has a half-life of 5,730 years, which means scientists can use it to date organic materials up to 50,000 years old. For example, an ancient bone or a wooden artifact can be dated using this method. Uranium-238 is an isotope that breaks down into lead-206. This process takes billions of years, and it has a half-life of 4.5 billion years. By measuring the ratio of uranium to lead in minerals, scientists can calculate the age of rocks. This method has been used to determine the age of the Earth and the Moon. Potassium-40 is a radioactive isotope that decays into stable argon-40. During this process, argon gets trapped inside the rock. Scientists can determine the age of a rock by measuring the ratio of potassium to argon. With a half-life of 1.3 billion years, this method is particularly useful for dating volcanic rocks. Rubidium-87 is an isotope that decays very slowly with a half-life of 48.8 billion years. When it decays, it turns into strontium-87. It's especially useful for understanding the formation of very old rocks and planets. This method helps geologists study the oldest rocks on Earth. Samarium-147 has a half-life of 106 billion years, making it useful for studying even the oldest events in the universe. The decay of this isotope into neodymium-143 is a valuable tool for determining the age of meteorites and lunar rocks. This method helps us understand the early solar system. Thorium-232 and uranium-235 decay into different stable isotopes. Thorium-232, with a half-life of 14 billion years, is used to date very old materials like ocean sediments. Uranium-235, with a half-life of 700 million years, is particularly useful for dating fossil fuels. Radioactive isotopes decay into stable isotopes at a constant rate. This rate of decay depends on the isotope's half-life. By measuring the amount of decayed isotope and comparing it to the initial amount, scientists can calculate the age of the material. Modern instruments can make these measurements with incredible accuracy. From carbon-14 to uranium-238, each isotope is a key to understanding the past. Thanks to these methods, we can better understand the history and evolution of our planet. These amazing properties of isotopes are a true revolution in science.